Hello everybody. In this video we're going to talk about what is Git, how it works, why you would want to use Git, and what the important commands are. Now, before we go any further, my name is David and I started playing around development code when I was, I don't know, can't remember, 6 or 7, and that was on a ZX81, way back. And for me, Git is one of the most useful tools I've ever come across. I use it every day because it follows the core Unix philosophy of doing one thing and doing it well. What is that one thing? Well, let's dive right in. First, what is Git? Git is an decentralized and uncentralized tool which is used to track changes in text files. Now, what do we mean by change tracking? Let's take the example of this small file here, which we've saved in its initial state. It has 3 lines. This is a small text file, and it's saved in its initial state, which we'll call commit 0, C0. Now, let's say we want to change the file. We want to add, say this is an important file instead of a small file. So we're replacing the line a small with an important. And this is the commit. We've saved this, and what we've done to save the commit, we say, okay, based on the initial state, the C0, we create a new state called C1, first commit 1. And that commit is made of a change and a parent commit. That change is a file that's impacted and the lines that are changed. This is what we call atomic changes. And so the commit saves the set of changes, that change, this specific change, but a set of changes, which files are impacted, and what the parent commit is. And this allows us to track changes in time. How do we create a commit? Well, let's say we're working on some code, on text files, and we have a number of changes compared to the saved state of these files. So here, for example, we have the change A in line 2 of file A, change B in line 5 of file B, change C in line 10 of file B. And if we do git add of file B, for example, what's going to happen is the 2 changes that concern file B are going to be added to what's called the index. And the index is kind of like a staging area where you put or remove, you add in and out files and changes that you intend to save. And you can actually add just one change, for example here, change B instead of change C. Now, once these changes are saved, or not actually saved, but recorded in the index of the changes that need to be saved to a commit, we use git commit -m with the message between quotes. The message is intended to convey what the intention of the changes are, what we're trying to do by these changes. And then we do git commit, and that saves the changes to the git tree. And this allows us, by doing this, to go back and forth between the different stages of the files in our project. So we can go back and forth in time and see who changed what, why, and when. What happens when 2 people work at the same time on the same project? And let's say we're all working on this file here. I don't know which file, it doesn't matter. And we're all at the same stage at the C2. Now, I want to do change X at line 4, and my friend Bob, who I'm working with, wants to do change Y at line 10. We've both created these commits that have the same parent. How do we continue? Well, we can merge our work together. We use the git command called git merge, which takes 2 commits that have the same parent, or that have a same parent up in the line, and by merging them we'll create a special commit which has 2 parents, which says, okay, this new commit takes this commit here and this commit here and creates a new line, a new dynasty of code. Here in this example, we change X at line 4 and change Y at line 10, and we say this is the new commit which takes this from this and takes this from this. What happens if we want to continue working independently? Well, we can, thank goodness. A typical use case for this would be, for example, if we have stable code, which represents the code that's in production for an application, a service, a web server, whatever. And we have the development code, which shows the work that's ongoing and that's unstable, which has bugs, which hasn't been tested. And so to do this, we have different kind of paths, different branches on the Git tree, and we can have markers that say, okay, I want to start working from this position. I want my code to represent this part of the tree. And so we can have this marker here on C4, which is stable, and this marker on this commit here, which represents my ongoing development work. And these markers are actually what we would call branches in Git. And to create a branch from a given commit, for example, from C2, we'd go git checkout -b and the branch name. So git checkout -b dev would create a new branch based on C2 if we were at C2. To switch from branch to branch, we just use the checkout command, which goes git checkout branch name, and that makes it very easy to switch between different versions of the code. So for example, let's say I'm working on a feature, I have a specific branch for that feature, and a bug comes up in production, and I want to fix that bug in production. I can't do it on my development code. What I do is I do a git checkout of the stable version, fix the code there, and commit that. And so my two workspaces are independent, and I can work on them independently by just switching between one and the other using git checkout. And then to combine the work back together, we use git merge with the branch name. So if we have here, we're on stable branch, and we want to bring in the code that's been done on dev, and we want to put that development work into production. We pull the work using git merge dev, and this will allow us to combine the work from dev into stable, and then we can test that and push that into production. So git merge branch name will bring the code from the branch name into the current branch. Now, how do we work remotely? Well, it's just a basic extension of this principle. Let's say we have user A, user B, and a kind of central repository hosted on a server, and that we're going to call origin. Let's say user A has a repository. He's done the work saved in C3, commit 3, and user B has done work saved in the commits. User B is going to push the work to the server with a git push, and the server is going to integrate this new commit C4 and say, okay, now on the current branch that we're working on, the latest commit is no longer C2, but it's C4. Now, if user A were now to try and push to the server, to the origin would say, no way, the parent commit you're working from is C2, we're at C4, you need to update. And the way to do that is actually to pull the work from the server, and then we have both together, C3 and C4 on our local repository, and then we merge them together to a C5 and then push that to the server. And then because it has the correct parent commit, then it will work. Now, to sum up so far, we've seen a number of commands. We've seen how we add changes to the index with git add of the path, how we save index to a commit, git commit -m message, how we create a branch with git checkout -b the branch name, how we switch to a branch with git checkout branch name, how we merge the contents of a branch into the current one with git merge branch name, how we push changes to the server, git push, and if there's nothing specified, it will push simply to the origin repository, how we pull changes with git pull, same comment, and there are two more commands that need to be mentioned here. If we want to start using Git in a repository, the initial thing to do is git init. This will initialize Git in the repository. And if we want to see the status of the current repository, git status. Now that's all from me. Please remember to like, to subscribe, to hit the notification bell, and I hope to see you soon. Thanks. Bye.